Okay, hello everyone. Today we are going to be going through the sign test. It's an easy statistical test that you have to do. It's the only statistical test that you have to do from start to end. All the other statistical tests, or inferential tests as they're known, like Wilcoxon and Mann-Whitney, you only need to know how to interpret the data. For the exam, you don't actually have to know how to do them. So the only stats test you have to know how to do from start to finish, and they ask these questions quite a lot, is the sign test. Now, in the exam, you may be asked to do the entire stats test, the entire sign test from start to end, or you may be asked just to do a part of it. You may be asked just to identify what the S number is, or you may be asked to identify, you know, the whether it's significant or not. So I'm going to go through the sign test. By the way, is, I would argue, embarrassingly easy. It is the easiest stats test you have to do. The ANOVAs and MANOVAs and MANCOVAs you have to do at university are so much more complicated, and you have to actually do those stats tests as well using quite complex programming. But for now, all you need to know is how to do the sign test. So let's begin. Okay, so as mentioned, it's the only thing you have to do from start to finish, and you can kind of see this in the specification. This is the section for statistical testing. Students should demonstrate knowledge and understanding of inferential testing and be familiar with the use of inferential tests. What we mean, and I cover this in another video, but what we mean by inferential tests are essentially stats tests. You have two different tests: descriptive statistics, mean, median, mode, range, standard deviation. Descriptive tests just tell you what the data is. They describe the data, hence the name of descriptive stats tests. But you also have inferential stats tests, and we're talking, like I say, the sign test, the MANOVAs, ANOVAs, Wilcoxon, unrelated t-test, chi-squared, and also sign tests as well. So in this case, introduction to statistical testing, the sign test, you need to know when to use the stats test and why you would use it, and also how to calculate it. Now, I'm going to go through that first bit, why you would use a sign test. Now, there are three reasons you would use any stats test. Three reasons, and you need to know these three reasons. Eventually, I want you to be able to do the entire sign test in under 30 seconds. That's how long it should take. So the first thing we're going to do is establish why you would use a sign test, under what conditions you would use a sign test, as opposed to chi-squared or Wilcoxon, so on and so forth. And the three reasons are: firstly, you've got a repeated measures design. So all of your participants are doing both conditions. So for example, if you were going to do a before and after of something, I don't know, measuring, let's have a look, measuring whether people have improved or gone down in their symptoms of depression before and after therapy. That would be a repeated measures design, all participants using all conditions. The second condition is that you're testing for a difference between, that should say two DVs actually, although same thing essentially. But you're basically testing for a difference. You're doing an experiment, but be careful, by the way, when you are asked why you would do a sign test, you have to say you are testing for a difference between two IVs, two TVs. Just go with two TVs. You can't say, oh, they're doing an experiment, right? You have to specifically say they are testing for a difference. And the last reason, this is probably the more complicated one for students, is understanding what the level of measurement is. If you have nominal / categorical data, you would be using a sign test. Now, say you had the first two, you're using repeated measures and you're testing for a difference, but you're looking at ordinal data, you would do a completely different stats test in this case. In this case, it would be Wilcoxon. So that is why you would do a stats test. This is what you need to do. Now, say you get a sign test in the exam. The first thing you need to do is figure out what the S and the N are. So the S is, I think it stands for sign, I think. It doesn't really matter. But the S is basically the number of the least frequently occurring sign, and I'll come on to that in a second. It's either going to be the amount of pluses or it's either going to be the minuses, but the number of the least frequently occurring sign, I'll demonstrate how easy this is in a second. And you also need to work out the N. The N is the number of participants in the study after you have taken out all of those scores who do not change. Now, I'm just going to show you an example here. Okay, so this is on my Google site. I might attach it to the bottom of the video as well. I've got a couple of exercises here in terms of sign tests, but let's have a look at the first one. A researcher wanted to know if running times would improve by listening to music compared to not listening to music. After running 100 meters, there's that little bit of operationalization, and researchers previously found that listening to music did improve running times. You need that for understanding what hypothesis you would use. Now, first thing you need to do is work out what the S and the N are. And the way you do this is you go down and you have to look at the first condition and the second condition, and you have to put a minus or a plus as opposed to how they did in the second condition. So obviously we've got a minus here because they have gone down. The first condition without music, they scored 12.3 seconds, which is actually very quick. And then with music, maybe they're playing a bit of pendulum, pump up their heart rate, their adrenaline. They've done better. They've run it in 11.5 seconds. Now, just to clear up some confusion here, some students would put a plus here because they said they've improved, they've gotten better, they've added to their score, kind of thing. It doesn't matter which way you put it around, if I'm going to be completely honest with you. It doesn't actually matter. I might explain this in class, but that is a minus there. As we go through, that is a minus, that is a minus, that's a minus, that's a minus. They've done better. And if we get to here, right, number 7, they've scored this exact same score. In that case, I'd put a 0. They haven't improved, or they haven't reduced their performance, or they haven't gotten worse. So they've scored exactly the same. That's quite important. They've gone down. Let's have a look. Can't see. They've gone down. They've gone up. They've. If you have a look here, in the first condition they scored 13.5. Second condition they scored 13.6. So that is gone. That has gone up. That's up. That's up. That's up. And that is the same. Okay. Now that would take roughly 10 seconds to do, right, if you were going at exam pace. The first thing we need to do is work out what the S and the N are. Now, remember, the S is the number of the least frequently occurring sign. So let me ask you, what is the least frequently occurring sign? Not between 0. Ignore the zeros. Completely ignore the zeros. They are dead to you now. The least frequently occurring sign in this case are the pluses, and there's only one of them in this case. So S equals 1. There you go. Right. How many people are in the condition after you take up the scores? Well, initially there are 14 people in the condition, but there are 2, as you can see, 2 scores. So 14 minus 2 equals 12, and those are the 2 numbers that you have. Now, so far so good. Then what you need to do, if I go back to the slides, and we've got our numbers now, is you then need to work out what the S value is compared to the critical value. Now, critical values are for a different video. Watch the inferential test video because you need to know what a critical values table are. All you need to know is that every stats test crunches down loads of numbers and craps out one single number. For the sign test, that's called the S value. Right, sometimes that's called the DF value. Sometimes it's called the R value, right? But that's the basic premise, is that stats tests, all of them, crunch numbers, give you one number. That is called your observed value. That is the value you observed in your data. You then take this observed value and you compare it to the right part of the critical values table. Now, as it so happens, I've got a critical values table here. Just a reminder for this, our S value is 1 and our N value is 12. So if I go down here, in fact, actually, I'm going to go on the harder critical values. I'm going to go on this one just here. So you obviously go down, n is here, you go down to 12 because our n was 12. But you need to know here what column you have to go across to. And this is actually quite important for this one in particular. It's actually quite important. Now, if we go back, a reminder that research had previously found that listening to music did improve running times. So you need to know whether or not we've got a directional hypothesis or a non-directional hypothesis. Hopefully you have figured out that we have a directional hypothesis here, or you would have a directional hypothesis, because previous research has indicated a direction to point your hypothesis in. So we have a directional hypothesis. So it's known as a one-tailed. So we need to work along here. That is significant to 99%. That is significant to 97%. But remember, you always start at 95% significance. So the column we are going across to, a reminder, we've got an n of 12. We need to figure out which column we're going across to out of these. One-tailed hypothesis is what we're going for. We're going for here. So actually, we are going for this column, for God's sake, this far column here. So the critical value here that we're looking for is 2. If you didn't understand that, it might be worth going back and watching that a couple of times, because it's not the sort of thing that people tend to understand unless you were really paying attention. But our critical value is 2. What does this mean? Now, generally at the bottom, although typically not here, generally at the bottom of every critical values, you will have the rule. The rule here is the observed value of 1. Remember, our S was 1. If we go back, the observed value, which is 1, must be equal to or less than the critical value of 2 to achieve significance. So we have actually got, and we have significance here, right? 1 needed to be less or equal to 2 to have significance, so we have significance. So we are at least 95% sure that it was the listening to music that was improving the running times and not some other extraneous variable like the shoes they were wearing or injuries or the weather. Right? We are 95% sure that the IV music or not listening to music did actually impact running times. We're still 5% sure that these findings are a freak, an accident, right? They're nothing to do with the IV whatsoever. We're 5% sure these are freak findings, but we're 95% sure that the IV did actually impact the DV in this case. That is how you do a sign test. That's how you do a sign test. Work out the S, work out the N, compare the S to the critical values and determine whether you've got significance. And ideally, you would do it to what level. So I'm just going to do a very quick, rapid one just here. So we've got another one here. So again, repeated measures, nominal, testing for a difference. A researcher wanted to see if meditation was effective in calming students before a test to see if they would score better. And students were measured on percentages achieved in the test. So as you can see here, first thing you need to do is work out your S, work out your N. So we've got plus there, we've got plus, pluses are so much harder. That's a minus, that's a plus, that's a plus, that's a zero. So they're dead to us. Fine. That's a minus. You did crap. Minus. God, these are crap. Plus. Okay, so in this case, our S is the least frequently occurring sign. So we've got 1, 2, 3. Right, so S equals 3. Oh, I've already got it down here. Because it saved me a lot of time. N equals 16. We started off with 17 people, but one person very rudely did not improve or did not go down. So S is 3, N is 16. Let's just pretend, I'm just going to go down to this one just here. So N equals 16. Go down to N. This one is slightly different test. We're looking at the second column just here. Second column, different critical values. So N was 16, go across. It's an interesting one, right? As you can see, where my cursor is, the critical value is 3. Our S value was 3. The observed value must be equal to or less than the critical value. In this case, is equal to. So we are, in this case, this is an interesting one, 95% sure the IV did affect the DV. And a reminder, the IV in this case was meditation. So we are 95% sure that the IV did impact the DV, which is students' performance. So in this case, we're 5% sure it was something else. Maybe they revised more for a test or whatever. We're 5% sure it's freak findings. We're 95% sure that it was actually the IV. But the question is, what's better than 95% confidence? 99% confidence. So what you always want to do, and AQA asked this for the first time in 2023, for the first time, they asked, to what extent are you confident? They didn't, before then, they'd always go, is it significant? And you just had to look at 95%. Is it significant? 95%. But in 2023, that's how you say it, they asked, to what extent are you confident? So as you can see here, S is 3, fine. Well, we've got we're 95%. But if we go to 99%, we don't have that significance because it's a 2, and we need 3 to be equal then or less than 2, and 3 is not equal to 2 or less than 2. It is more than 2. So in this case, we can say we are 95% confident that meditation does improve student performance. We're 95% confident, but we cannot say with statistical confidence that we are 99%. So we are somewhere between 95 and 99% confident, maybe 97, maybe 98, maybe 96, but we cannot say we are 99% confident. That is how you do a sign test. Just for summary, work out the S, work out the N, take the S and compare it to the right part of the critical values table. That is the hardest part, by the way, because they will give you different tables, and sometimes you have to work out whether it's one-tailed or two-tailed. But you take the S, the observed value, you compare it to the critical value to determine to what extent you are confident, starting at 95% confidence. I believe that is everything. Just a reminder, the sign test you should be able to do in 30 seconds. You should be able to do it in 30 seconds, a minute tops. But if you do get it, if you do understand it, you should be able to walk away with quite a few marks. That is everything. I hope that was useful. And yeah, peace out.